We're going to review what we did in class yesterday. This is going to be a talk about the vector space model of information retrieval. I hope my technology is working here. Whoops. So this is the vector space model. And I'm going to break this up into a bunch of short videos that I hope you'll watch, and we'll clear up any of the issues that we encountered last night. So again, I want to suppose that we have a corpus of documents, and it's a very small corpus. It's just got 4 documents in it. So here they are. And for the moment, I want to assume that we've got cat appearing in all of these documents. And let's assume that we have dog that is appearing like that. And then we have mouse. Now, there are a couple of things we have to do here. This is all notational. This is document D1. This is document D sub 2, D sub 3, D sub 4. N, capital N, is equal to the total number of documents. Which in this situation is equal to 4. Now, something else we have to do, this is very important. We have to have an ordered list of all the words that appear here. So my ordered list, and notice by order, notice I'm using these brackets here. I'm going to say, well, it's cat, dog, mouse. Now, what I've done here is I've just listed these alphabetically so that it helps me remember it. The order is not important, but once you set this order, then it becomes important. And the thing to remember now is that when we are going to be creating vectors for each one of these documents here, the vectors, we can see right over here, there are a total of 3 words in here. So each one of the vectors for these 4 documents will be a vector of 3. And in fact, the vectors will be referring to somehow some mathematical quantity that is related to these words here. So I'm going to come over here and I'm going to say that word 1 is equal to cat, and I'm going to say that word 2 is equal to dog, and I'm going to say that word 3 is equal to mouse. Now, the first thing that I want to talk about here is this thing that we call the inverse document frequency. And that's sometimes referred to as the IDF. And the observation that we made in class yesterday is that suppose this is my corpus of documents, and I am I have something that I'm trying to find out, and I'm hoping that somehow I can type some words in a search box, and the search box can return to me the document that's going to provide me the information I want most. So what the inverse document frequency is trying to determine is it's taking a look at the documents here and it's saying, well, look at these word cat. The word cat appears in every one of the documents. So the word cat is really not a good discriminator of documents. It really doesn't separate any one document from the other. But then if I come over here and I notice that dog is only in 2 of the 4 documents, so it seems like dog might be a word that is a better discriminator. And if I come over here and I notice that mouse, well, mouse only appears in one word, in one document, so mouse is even a better discriminator. So what the inverse document frequency is telling us is it's somehow a measure of how many documents contain a particular word that we're looking for. So what I want to note here is I want to introduce some new notation, and I want to come over here and I want to say that n of some w is equal to the number of documents that contain the word W. So if we come back here, if I want to know what is n of cat, I come back to my documents up here, and I go, well, cat appeared in 4 different documents, so n of cat is equal to 4. N of dog is equal to, and I come up here, and dog appears in 2 documents. So n of dog is equal to 2. And n of mouse is equal to, and I come back up here, and I see that mouse appeared in 1 document. So I come up here, and I say n of mouse is equal to 1. So we define the inverse document frequency of W is equal to log base 2 of n, and that's capital N. Remember, capital N is the total number of documents, and I'm going to divide this by n of W. Okay, so if I come over here, I get that the inverse document frequency of cat, that would be equal to log base 2 of 4 over 4, and that's equal to log base 2 of 1, and that's equal to 0. I know in class we said that sometimes what people do is they add 1 to this expression. That's fine. We're not going to do it here. If I come over here and I talk about the IDF of dog, that is equal to log base 2 of 4 over n of dog, which is log base 2 of 4 over 2, which is log base 2 of 2, which is equal to 1. And I have that the IDF of mouse is equal to log of 4 over the number of times that mouse appears is 1. So that's equal to log base 2 of 4, and that's equal to 2. So notice here that cat, which was in all the documents, has an inverse document frequency of 0. Dog, which appeared in 2 out of 4, has an inverse document frequency of 1, which is bigger than 0. It seems to indicate that this is a more important word because it appears in less documents. And if I take a look at mouse, okay, that has an inverse document frequency of 2. It appears in only 1 document, so it seems like this is even a more important word than dog. 0, 1, 2. I want to notice over here, and this is just a notational thing, I could call this, notice I've called it the IDF of cat. I could also call it the IDF of W1, or I could even call it the IDF and put a subscript of 1 there. This could equal the IDF of W2, and I could even write that as the IDF of 2, and I'll bet you can figure out what this could be too. So this is all just notational stuff. okay? And the IDF, again, is, we talked about this in class. I like to think of the IDF as an external measure. Everybody okay so far? Okay. Now what I want to do is I want to come back here and I want to change a few things about these documents that I have here. So what I want to do is I want to come over here and I want to put in, there's another dog here and there's another mouse here. And I want to come over here and I'll say dog, dog, and over here I'll say cat, like that. Now, the thing that I want you to note here is that by increasing the number of times that a word appears inside of the document, that still doesn't change the inverse document frequency. That's why I call the inverse document frequency an external measure. Okay? It's not changing by repeating the word inside of a document, the IDF doesn't change. But now what I want to do is I want to measure what I call an internal measure. And an internal measure has to do with how many times words appear within a document. So I'm going to try and figure out how I can conveniently scroll this. I want you to note over here that I'm going to write this down here at the bottom here, and it's going to help us a little bit. The number of times that cat appears is once. The number of times that dog appears is twice, and the number of times that mouse appeared was twice. I come over here and cat appeared once, and dog appeared 3 times, and mouse appeared 0 times. And over here, cat appeared twice, and dog appeared 0 times, mouse appeared 0 times. And over here, cat appeared once, dog appeared 0 times, and mouse appeared 0 times. Everybody got that? I'm just doing a count here of how many times. And again, notice that I calculated this in the same order that I specified my words. I did it in cat, dog, and mouse. So what I can do is I can come over here and I can talk about the term frequency. And the notation that we use here is you'll sometimes see, we'll talk about the term frequency of W sub I, comma, D sub J. And that is equal to the number of times W sub I appeared in document D sub J. So notice this is an internal measure. I write this in capital letters for emphasis. In other words, if we come back over here and we look at this, we can see that the term frequency for cat in D1 is 1. The term frequency for dog in D1 is 2. But notice that if I come over here, the term frequency for dog in D2 is 3. The term frequency for dog in D3 is 0. In other words, the term frequency differs from one document to the other, which is why, again, when it comes to talking about the term frequency, we have to specify 2 things. We have to specify the word and the document. But notice that for the inverse document frequency, that's a global measure. We just had to specify the word. Okay, we didn't have to specify anything about documents. Inverse document frequency We don't need to know the document, we just need to know the word. So when I come over here, okay, so we have the term frequency of cat D1. We have the term frequency of dog D1. And we have the term frequency of mouse D1. And we just calculated them right over here. It was 1, 2, and 2. Likewise, we can come over here and we can calculate all these other quantities here. We can talk about the term frequency of cat in D2, the term frequency of dog D2, and the term frequency of mouse D2. And that would be 1, 3, and 0. We can talk about the term frequency of cat D3, dog D3, mouse D3. And again, I come back and look at my thing here. Cat appeared twice. Everything else was 0. And then finally, we can come down here and we could talk about the term frequency of cat D4, term frequency dog D4, and the term frequency of mouse D4. And that is equal to 1, 0, 0. Okay. I hope everybody has that. That's very straightforward. Now what we do is we come up with one more thing here. And again, I want to just reiterate, remember, this we said is an internal measure, which means that for any word we have to also specify a document. Notice the term frequency of cat in D1 could be different than the term frequency of cat in D3. This is document dependent, where the inverse document frequency isn't. So finally we come up with this thing called the normalized term frequency. NTF. And we talk about the NTF of WI DJ like that. And what we have to do here is we come over here, and I want you to just think about this as I talk about it. We consider the max of the term frequency of W1, comma, DJ, term frequency W2 in DJ, comma, all the way up to the term frequency of WM in DJ. Now that looks very complicated over here. Again, what I'm trying to do here is I'm saying, for example, come over here and I say find the maximum number you see here. And the maximum number I see here is 2. And I say, why don't we let that equal some number k? Okay? And then what happens is I come down here and I say that the the normalized term frequency of Wi in d sub j would just be equal to the term frequency of Wi in d sub j, and we divide it by k. So for example, if I come back here, I would note that k is equal to 2. In this example right here, k would be equal to 3. It's the biggest of all the numbers here. In this example right here, k would be equal to 2. And in this example right here, k is equal to 1. So the biggest one here is 2. To get the normalized term frequency of these three terms, I would divide everything by 2, and I would get 1/2, 1, and 1. Over here, I would divide everything by 3, and I would get 1/3, 1, and 0. Over here, I would divide everything by 2, and I'd get 1, 0, 0. And over here, I would divide by 1, and I would just get 1, 0, 0. So I'm going to come over here, and I'm just going to make a little table here. And I'm going to have cat, dog, mouse. And over here, I'm going to say D1, and then D2, D3, D4. And I'm going to come back up here, and I said, okay, that for D1, k is equal to 2. I'm going to divide by 2, so I get 1/2, 1, and 1. So I come over here. This would be 1/2, 1, and 1. I'm going to go to D2, and I see k is equal to 3. I divide all of these by 3. I get 1/3, 1, and 0. I come over here to document D3. K is 2. I divide by 2, so I get 1, 0, 0. And I come over here to document D4. K is equal to 1. I divide all of these by 1. It just gives me 1, 0, 0. And this you could think of this is our normalized term frequency table. Okay? So now we get to the final thing. The final part of this tape, we'll be making another one shortly, is how do we make the vectors for each document? Well, okay. First of all, every vector including the query vector will be the same size. So this is very, very important, okay? And remember, word order is important. So for these 4 documents that we had, remember there were a total of 3 words. So D1 is going to be a vector that has 3 components in it. And D2 is going to be a component, or is going to be a vector that also has 3 components in it. And D3 will be the same thing. And D4 will also be the same thing. Now the question is what goes in each one of these components? Now remember, these components here have something to do with word 1. This has something to do with word 2. This has something to do with word 3. Well, the first thing that's going to go in here is this is going to be, and I'm going to be using some of the abbreviations I gave you before. So this is going to be the IDF, the inverse document frequency 1. In other words, the inverse document frequency of the first word. So what was the first word? The first word, again, if we go back to the original here, remember we said the first word was cat, and we said, okay, we calculated the inverse document frequency of cat. It was actually 0. But again, I want you to appreciate that that is what would go over here. Likewise, what's going to go over here, this would be the inverse document frequency of of the second word. So I'm going to call that IDF2, 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 and I think you can see the third component here is going to be IDF3, 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 IDF3. Okay, again, we calculated those numbers. The inverse document frequency of the first word was 0. The inverse document frequency of the second word was 1. The inverse document frequency of the third word was 2. So when I come over here, these are all going to be zeros. These are all going to be 1s. These are all going to be 2s. But now we're not done here. This is going to be times the normalized term frequency of W1, comma, D1. And this over here is going to be times the normalized term frequency of W2, comma, D1. And this over here is going to be times the normalized term frequency of W3, comma, D1. Okay? So first of all, what's going to happen over here is remember, this was a 0, this was a 1, this was a 2. So now I have to look for the normalized term frequency of cat in D1. The normalized term frequency of cat in D1 was 1/2. The normalized term frequency of dog in D1 was 1. And the normalized term frequency of mouse in D1 was also a 1. Everybody get it? I just got those values right from this table right here. Now we can go ahead and figure out all these other ones here. We can fill in, let's fill in a few things here. First of all, we just know that this is going to be 0 times something, 0 times something, 0 times something. This will be 1 times something, 1 times something, 1 times something, 2 times something, 2 times something, 2 times something, and 2 times something. And we can just come over here and we can figure this out. For D2, it was 1/3, 1, and 0. So it's going to be 1/3, 1, and 0. Remember, this is going to be times the normalized term frequency of W1 in D2. Okay? I'm getting a little cramped here. I think you can all figure out what's going on here. When I come down here for document D3, D3 is 1, 0, 0. So this is 1, 0, 0. And when I come over here, this one is also 1, 0, 0. So this down here is 1, 0, 0. So when we come down here and we finish this up, D1 is equal to 0, 1, 2. D2 is equal to 0, 1, 0. D3 is equal to 0, 0, 0. D4 is also equal to 0, 0, 0. Okay. And again, I just want to write this out so that you can see this. When we did D1, D1 is equal to, and I'm going to write this out very long here now, it's the normalized term frequency of the first word times, I'm sorry, this is wrong. I think I have an eraser here. There is an eraser there. Look at that. Let me go back. It's the inverse document frequency of 1 times the normalized term frequency of W1 in D1, comma, the inverse document frequency of the second word times the normalized term frequency of the second word in D1, comma, the inverse document frequency of the third word times the normalized term frequency of the third word in the first document, like that. And this is a vector, and it's made up of these three components. If I want to find out what document number 2 would look like, just go in there and change this right here from D1 over here to D2. If you want to find it out for D3, change it for D3. In other words, it's this right here. This changes for each vector. And I think this is a good place to stop right now.